Welcome to aminacademy.com in electrical engineering regarding electric potential and potential difference. Let us do some solving problem. Look at this example. You have a 12-volt motorcycle battery that can move 5000 coulombs of charge and a 12-volt car battery that can move 60,000 coulombs of charge. How much energy does each deliver? Assume that the numerical value of each charge is accurate to three significant figures. Here, two types of batteries there. First, motorcycle. Here, car battery. Both are having 12-volt battery. Now, Q for motorcycle charge is 5000 coulomb. Here, Q is for car Q 60,000 coulombs. How much energy does each deliver? That energy delta U per cycle, delta U for motorcycle, delta U equal CV, which is equal C is 12, C is 5000, 5000 into 12, which gives 7.2 into 10 power 5 joules. Here, the car battery energy delivered is delta U equal to QV, delta equal to, this is Q. QV, Q is 60,000 into volt is 12. Here this is 60, 6 into 10 power 4 joules. Here 7.2 into 10 power 5 joules. Here voltage and energy are related, but they are not the same thing. For example, the voltage of the batteries are identical, but the energy supplied by each is quite different. A car battery has a much larger engine to start than a motorcycle. Note also that as a battery is discharged, some of its energy is used internally and its terminal voltage drops, such as when headlights dim because of a depleted car battery. The energy supplied by the battery is still calculated as in this example, but not all of the energy is available for external use because it's not fully charged. Next question. When 12-volt car battery powers a single 30 watts headlight, how many electrons pass through it in each seconds? Here, delta U, the energy equal Q delta V. Therefore, on this Q equal delta U by delta V equal internal energy is minus 30 watts over V equal 12-volt battery. 12-volt battery which gives minus 2.5 coulombs. Now Q equal, we got it. Therefore, number of electrons per second. Number of electron per second equal, number of electron per second is minus 2.5 coulombs over charge of each electron is minus 1.6 because negative charge, and 10 power charge of each electron is this coulombs, this is coulombs, this is coulomb per second, gives 1.56 into 10 power 19 electron. This much electron per second is passing through a particular position. This is a very large number. It is no wonder that we do not ordinarily observe individual electrons with so many being present in ordinary system. That means in electricity had been in use for many decades because it was determined that the moving charges in many circumstances were negative. Positive charge moving in the opposite direction of negative charge often produces identical effects. This makes it difficult to determine which is moving or whether both are moving. So, number of electron passing through per second is 1.56 in 10 raised to 19 electrons. Next question, calculate your final speed. Look at here. Calculate a final speed of free electron accelerated from rest through a potential difference of 100 volts, assuming that its numerical value is accurate to read signal figure. Here, voltage is given 100 volt and number of, calculate the final speed of free electron. Here, conservation of energy, law of conservation of total energy initially, that is kinetic energy initial plus internal energy initial, which is equal kinetic energy final plus internal energy final. Now we know the relation QV equal kinetic energy mv square over by 2. QV is equivalent to kinetic energy. From this would be here V equal square root of 2QV over M. So for this one here, 2 charge of each electron is minus 1.6 into 10 power minus 19 coulomb into V, voltage is 100 joules per coulomb. That is 1 volt is 100 joules per coulomb. This minus 100 over mass of one electron is 9.1 into 10 raised to minus 31. So by using this calculation and square root, which gives approximately 5.93 into 10 power 6 meter per second. Such a high speed of electron passing through. Next question. Dry air can support a maximum electric field strength of about 3 into 10 power 6 3 into 10 power 6 3 into 10 power 6 above the value of field creates enough ionization in the air to make air as a conductor. This follows a discharge or spark that reduces the field. What then is the maximum voltage between the two parallel conducting plates? 2.5 centimeter of dry air. That means two plates separated 2.5 centimeter. In between dielectric is air. How much this much voltage is? That is 3 into 10 power 6 volt per meter is dielectric strength. That means that much voltage is enough to break the dielectric. That means we have to calculate maximum voltage between two parallel conducting plates. Here, look at here that the potential difference or voltage between the plate, PD, potential difference between two parallel plates equal, that is VAB, VAB equal to E into D. Therefore, E is 3 into 10 power 6 volt per meter, 3 into 10 power 6 volts per meter, and distance is 2.5 centimeter is 2.5 into 10 power minus 2, which gives 7.5 into 10 power 4 volt. That means to break the dielectric between the two plates separated 2.5 centimeter is 7.5 into 10 power 4 volt we need to break the dielectric. Therefore, VAB equal to supplying 10.4, it gives 750 kilovolt. Kilovolt means 1000 volts. Not 750. Kilovolt. Next question. An electron gun has parallel plates separated 4 centimeter and gives electron 25 kilo electron volt of energy. That much energy it supplies. What is the electric field strength between the plates? Electric field strength you have to find. The second one, what force would this field exert on a piece of plastic with 0.5 microcoulomb charge that gets between the plates? Here, E equal, first, electric potential equal VAB over distance. That is equal 25 kilovolt over meter, 25 keV, and distance is 4 centimeter, which is equal 4 into 10 power minus 2, which gives 6.25 into 10 power 5 volt meter. Then second part, What force would this field exerts on a piece of plastic? 0.5 microcoulomb. If the force equal Q into E, which is equal Q equal zero point 0.5 into 10 power minus 6 into 6.25 E, 6.25 into 10 power 5, which gives 0.313 Newton. Because coulomb is 0.5 microcoulomb, that is 0.5 in 10 raised to. We have done. Please subscribe our YouTube channel.